Right. So, what we will do in this section is analyze the absenteeism model with the help of the Tableau software. You may have noticed that we said the absenteeism model instead of the absenteeism data set, and that was intentional. Here, we will not only analyze the data, but also the predictions of our logistic regression model based on 40 new observations. Thus, we can explore the inputs that seem to be most important according to our model. Obtaining such information is key for the management of a company. Why? Because this allows us to compare how powerful this model is in general, but also with respect to other machine learning models, such as neural networks, random forests, or SVMs. All right, after this short clarification, let's start Tableau. The first thing to do is connect to a data source. We'd like this to be the CSV file containing the data set with predicted outputs. Since the CSVs are a text format, we need to click on Text File. Then select and open the relevant file. Our data will be visualized immediately. It is also good to take advantage of the opportunity to scroll horizontally and vertically to verify that we haven't made any obvious mistakes while importing the information we'll be working on later. Everything seems all right. We can proceed by going to Sheet 1. In it, we'll plot age versus probability. So let's give it a meaningful name. Done. Remember that you should always have an idea of the graph you would like to obtain from your analysis before you start working on it. For instance, in this situation, we may think that it'll be very useful to plot the average probability value on the vertical line and the respective age values on the horizontal one. This is the accepted standard, so if you organize the graph the other way around, having probability on the horizontal line and age on the vertical one, it would look awkward to most people. So, creating this image will be our task for this lesson. Great! First, remember that month value, age, body mass index, and so on are all data fields, as they correspond to the columns we have in our data set. See? Having said that, let's go back to our sheet and drag the age data field to the column section. Okay, we see nothing but a long, thick line showing an age of 1,481 as we hover above it. Why such a large number? Nobody can be that old. The reason is that, by default, Tableau aggregates values that have been given the role of measures. These are numeric, quantitative values that can be measured, and hence aggregated. Aggregating values means that one can count them, obtain their sum, extract their average, and more. That's why Tableau gave us the sum of the ages of all individuals from our table automatically. To correct this erroneous representation, we can click on this little triangle that appears on the right side of the age field as we hover above it. Then we can select Dimension. Now we can see the different ages for which we have data. And the reason for this is that dimensions in Tableau contain qualitative values that can be categorized or segmented. As a result, in this example, we see a line mark for each distinct age recorded in our observations. If we drag the prediction field to the rows section, its values will be summed automatically. So, as we did with age, we must set prediction to be treated as a dimension. And this is great, because now we can see whether our model has predicted that an individual will be excessively absent from work, prediction value 1, or not, prediction value 0. However, by looking at this graph, we can't conclude whether a person above or below a certain age is expected to be excessively absent from their workplace in general. we can't see how many observations are behind every dot. In this visualization, a dot could represent 1, 5, 10, or more individuals of the same age. Could we improve this graph somehow? Sure, let's take the probability values instead. They are floats, and their values are between 0 and 1 inclusive. So, we can remove the prediction field by dragging it out of any of the sections containing various options. Then, we will replace it with probability and turn it into a dimension. Compared to the previous graph, this one shows that most of the individuals in our dataset were 40 years old or younger, right? This became clear only because our visualization now allows us to see multiple observations for every age. As a side note, let me tell you that the type of graph Tableau chose for this particular data was shape. It is the one that corresponds to the so-called scatter plot, which is a visualization of a set of points plotted on the horizontal and vertical axes. The graph you see is a typical example of a scatter plot, and since this is the exact type we need here, I'll select shape. All right. Going back to our initial task, which was to plot the average probability value against the feature age, we can turn the probability value back into a measure and designate we want to see the average value displayed. Now, you can hover over every dot and see the age and the average probability value it corresponds to. For instance, there's only a 29% chance that an individual who is 31 will be absent from work for more than 3 hours. Great! There's one final touch I'd like to make to this graph. It is to express the probability values as a percentage. To do this, right-click on the vertical line of the visualization and select Format. Then, to change the way the numbers are expressed on the scale, expand this drop-down menu and choose Percentage. Finally, remove the digits after the decimal point. Click outside the box that opened, and you will be able to proceed with the adjustments made. This looks good. However, the lowest and highest probability values displayed must be 0 and 100, respectively, and they aren't. To change them, double-click on the same vertical line. Opt for a fixed range, and set the n to be equal to 1. Close the window, and here we go. We ended up with the graph that we are aiming for at the beginning. Do you agree? We must admit we could have come directly to the solution by dragging the age field in the columns section and then setting average probability as the field in the rows section. Nevertheless, we chose to do a bit more work in Tableau as this might be useful. Feel free to play around with the other data fields and check if you can obtain some meaningful graphs. Thus, sorry for the cliché, but practice makes perfect. Thanks for watching.